All right, welcome everyone. Welcome to this Q3 event for GDG Cloud Montreal. So we have a few things going today. I'm going to start sharing my other slide deck. So that's all we do, sharing slide deck. So give me 2 seconds. We are recording, so that way we're good for posterity. Let me do a little sharing and do a little full screen here. All right, then. Yes, I am recording, so good. So that's my reminder. Let me go in presenter mode, so it's nicer. So hello, everyone. So welcome to this Q3 event for GDG Cloud Montreal. Well, we'll do, that's a long one, automate annotations for Vertex AI text data sets with Cloud Vision API and BigQuery. We'll also have a little gravy extra with some other Google services mix in there. As usual, is the proposed agenda. So you'll meet your speakers. Actually, we'll have a formal intro a bit later. The way to ask questions during the event. We'll go through a few blog posts where you have mentioned, just really small ones, so our friend Mohammed can actually have enough time to do his thing. Then we'll go through Mohammed's presentation, and then we'll wrap things up. So our speakers for today, and Mohammed, you'll have like the time to intro you properly. I'm just going through the intro deck, so don't worry. Well, I'm Stacy Verano. I'm a senior pre-sales cloud engineer for SADA, and joining me today is Mohammed Al Ansari. He's a staff partner developer advocate at Google. Super excited to have him join us and doing like a killer demo. So everybody wants to jump in and do some Vertex AI stuff. um, Quick one, if you want to ask questions during the event, at the top of on the right side, if you go in the chat area, you have the public chat where you see me saying that, hey, we're starting in a minute. There's also a Q&A section. In the Q&A piece, which is actually where I've dropped my question. If you want to, just like drop it in there so we can have like a Q&A going straight from there, and we'll get the output from it at the end also, which will be part of the recording. So that's basically how it goes. Pretty simple. Uh, so we'll just jump right in. Be mindful of time around like the cool posts worthy of sharing. So it's been a while since the last meetup. Of course, we're each quarter, but if you do one at the start of a quarter and the other one at the end of the quarter, it's been a while. So I went through a few cool things I wanted to show up. One of them is actually leveraging well, of course, like Google Cloud to protect and find PII information. So there's a feature in BigQuery called auto tagging, automatic DLP, that's able to identify sensitive data. So that way, anything that you put like in tables and it can actually be scanned and all that. And it also comes with a dashboard telling you, well, it comes with, you still have to do it yourself and do the connection. But I mean, there's a dashboard in Data Studio you can leverage to actually see and get a report on, was there any PII data captured before it's like a write on a table or something. So you'll have the detailed findings through that Data Studio dashboard. So that's pretty sweet. As usual, I will share all the links of all those posts in the chat, so that way everybody has them. If not, it's a nightmare to just try to cut and paste everything that I'm putting there. So when I'm done, I'll wrap it up and I'll paste it in there. So cool stuff. A way of doing like ongoing view of your sensitive data through automatic DLP with BigQuery. Second one's an old one, but still, it was a great recap of everything that we can do in GCP. So if you want to build a secure, so we're talking more DevSecOps than just like DevOps, but if you want to build like a secure CI/CD pipeline, you want to use like 100% Google Cloud tooling, then this blog post is for you. So basically, it goes from vulnerability scanning for container images, like binary authorization, like who can do what and where through policies. So same thing goes for having a secure GKE cluster in place, and also like on the policy side, depending, regardless of what you do, like there's a bunch of policies you can implement in your pipeline. Depending on what you do, could be it could be as simple as Terraform policies that you want to embed with Cloud Build, so you're able to do that. So it covers all of those little elements. So I found it was really worthy of mention. And again, I'll share the link at the end of the blog post section. Well, the next one, actually, there a lot of people are using PubSub, and there's one thing. Well, I don't want to say it was missing, but it was kind of a buried treasure. So, but right now, actually, right, if you go in PubSub, you're actually able to get metrics out of the box. They're baked in the interface, so that's pretty nice. So instead of trying to go and get the logs, get something, maybe then bring that back in whatever form that you want to use it, then you have something that's baked in. So you can click on any topics of subscription, you get some details. So that's a great addition to PubSub, having that baked in, get you that visibility. So pretty nice feature. Totally worthy of mention for all of our friends using PubSub right now. I know there's not a ton of us, but I know that Etienne is using it. So Etienne will be happy with that one. All right. So a new service that was also put in place was Google Cloud Backup and DR. So basically, like if you want to have like a full DR scenario, not the one top right where everybody screams and runs everywhere, but actually have something that makes sense. You need something that that you can take incremental backups like forever. Then of course you have your service, and then you have like whatever am I backupping? Is it VMs? Is it persistent disk? Is it snapshot? Like whatever like I need. So behind this, there was an acquisition made by Google a while ago called Actifio. Actifio Go is still something you can get straight from the marketplace, but the backup and DR service, it's kind of like the embedded, baked Actifio inside the console itself. So great way to go see about it. It's right now from the article you'll get the information. The actual service is going to go like GA turned on. They say like late September. Well, we're on the 21st, so your worst comes to worst, you're like 9 days from getting it. So you can have a look at that. So and the other one was just it's not about, well, it's a blog post, but not so long ago in June, actually, Cloud Armor, so Google service, the web application firewall, was able to block the largest layer 7 DDoS attack that came in with 46 million requests per second, roughly. Like the article says, it's like you're checking like all the traffic of like Wikipedia for a day, but in 10 seconds. And Cloud Armor, which is awesome, and with adaptive protection, was able to actually just say, "Yep, man, you're not passing through my web application firewall." So nice shout out for that product. To be honest, it's great, and yeah, it's always nice to see like what's available in GCP. So I thought I would bring that out. So if you're ever looking for a WAF on GCP, well, you know where to look. That's the I think it's second to last. So we're Google Next 22 is around the corner. So it's going to be October 11th to 13th. So feel free to register. It's completely remote, so there you can actually in a few places they have watch parties. So depending on the city you are, I know there's something in Toronto. You can just go there, but please register. It's fully free. If you can't attend, you can watch the all the videos after. But it's a great 3 days of like what's new with Google Cloud, all the services, and you'll go through Next 22. So if you want, like, scan the QR code, you'll have the link below. But please register. It's really nice. And last one is a shameless plug. Sorry, this is it's supposed to be a community meetup, but it's a shameless plug. Whoever wants to learn more about the future of platforming with GKE and NTOS, there's an event coming at Google Montreal. Hamza, the CE from Google, will run this with yours truly. So we'll do a hybrid event. It's a half day, so from noon to 3 p.m. If you're in Montreal and you want to attend in person, you will be able to do so. You'll also be able to eat at Google, which is always nice, and also get a Google Office tour at the end. So if you're in Montreal area, please join us. If you're remote, no problem. If you're remote, Sara will also send some vouchers for those who can't eat with us at Google, so that they are part, they're still part of the event also. So that's just my shameless plug, wrapping up. But if you want to, feel free. So those are the blog post links. So you have like 5 seconds to cut and paste all of this or memorize it. So I'll paste it in the chat, so you don't have to worry about that. So yes, Elizabeth, I saw your question. Yes, the Montreal event will also be online. So it's fully hybrid. If you register, you just select whoever. Say, oh yeah, I got this from Sarah, and then you'll be part of the people who can actually get a like a voucher for food or so you can be home and attend the event. So those are blog posts. Of course, I will share that with you. And now up to the serious stuff. So we'll go with automated annotation for Vertex AI text data sets with Cloud Vision API and BigQuery. So Mohammed is gonna do this. Just I add one more slide regarding what we're solving for, which is something that Mohammed said, which is like really good. So ML practitioners faces challenges in annotation large training data sets. So in this session, we will demonstrate a Jupyter Notebook that helps you automate the annotation of a training data set where data has been manually extracted from before with the help of Cloud Vision API and BigQuery. So, and as a bonus, I was mentioning that before, we'll be able to use the resulting model to import data directly in Google Drive from Google Drive and Gmail into G Sheet. So that's what we're going to solve for. And I'm passing the mic to Mohammed to intro himself. I'll stop sharing so you can start sharing. Here we go. And I'll paste the links in the chat, everybody. Yep, no worries. So, Mohammed, welcome.
Thank you. Thank you very much. I love all the movie reference that you have on those slides. So.
Yeah, it keeps me busy.
Yeah. Cool. All right. Well, thank you for me. And again, I know the title is a mouthful, but hopefully I'll be able to simplify it, and show you the various steps that I've used to build the solution. So again, we're talking about automating annotations for a Vertex AI text dataset using Cloud Vision API and BigQuery. And I'm going to talk about the specifics. What does that mean? What are the components involved? And like Sissy said, like what are we solving for? So with that. So my name is Mohammed Al Ansari. I'm based out of Toronto. I work as a partner developer advocate at Workspace, which means I work with strategic partners to help them integrate with Workspace. But prior to joining this team a couple of months ago, I was part of GCP as a customer engineer. So the work that I'm demonstrating today was actually done, when I was doing that. I've got about 18 plus experience of systems architecture and software development, which means that I've seen a lot of the good and the bad and the ugly. Um, I'm married with one lovely daughter, and I'm based of Toronto, as I said. So my goals for today are as follows. I'm going to explain how you can pre-process a data set using Vision API and BigQuery to train a Node2ML Vertex AI entity extraction model. I'm going to demonstrate how to do it in Jupyter Notebook, so we'll do a live demo. And then I'm going to show how to evaluate the trained model, look at the statistics, and as a bonus, I'm going to show you how to integrate that model in Google Workspace. I don't know if you know this, but you can extend Google Workspace to build add-ons so that you can build a custom application that you can deploy within Drive, Gmail, and Sheets. And we're going to show how that's done to integrate with GCP. If you have any questions, please feel free to drop them in the chat. I have two monitors, so hopefully I'll keep an eye. If I miss one, please say, let me know. But let's start with this scenario. So has this ever happened to you? Being engineers and working in an engineering department, somebody comes up to you, your boss, and says, hey, I've got this new X technology that either himself or, themselves or their VP has heard of, and they want to integrate it. And I can't say that anything is further from the truth when it comes to AI and ML. When this became a buzzword, everybody is like, we want to add AI, we want to add ML to everything. And in this comic that's taken from the Machine Learning comic series from Google AI, which is an amazing place to learn AI ML. An engineer, Martha was working in the engineering team, gets her manager who's asking about like, yeah, let's see, our VP asked, learned about ML, let's add it to everything, and can you lead that? And I think some of us have been in that, scenario in their jobs where their managers come with a new thing and you have no time, no resources, you want to scale quickly. And my goal today is to show you how to leverage some of the existing data that your organization have been collecting to accelerate your journey into machine learning. So let's talk about a couple of the top challenges that machine learning practitioners face. So the first is finding large and relevant data sets to train models on. So let's say you want to dig deeper into ML, you want to build a model that helps you solve a problem. How do we train it? And you need good data to train it, and that means a large and relevant data set. So finding that data is a challenge. The other challenge is how do you annotate those data sets? And annotation is the process where you go through data and tell the model, like, for example, if we're doing text annotation, like this text means this. And you do it repeatedly for your data set so that the model can learn how to identify these entities, for example. But the good news is you may already have this data. So somebody has been extracting data manually for years. If you're trying to build a new solution to automate a process, then it means somebody has been doing that process manually, which means that the data that you're looking for to help you train already exists somewhere, either in a shared folder, in a database, in a spreadsheet somewhere. Could be in PDF, could be in a different format. And how do you leverage this data to simplify your training? So let's walk through an example. Let's say that we have this hypothetical company called Super Creative Inventors Inc. Now, this is a small company that's been helping thousands of inventors over 15 years to file patent applications. And to file a patent application, the first thing you need to do, or one of the things, is do a patent search to make sure that what you're claiming to have invented does not exist already and is not patented already. So they've been doing this manually for many years. They've been manually extracting data. Somebody looks at a PDF that includes the patent data. They extract the data into a SQL database, and then they use that for their searches. Now, the manual process is very slow. It's prone to human error, copy and paste, etc. It's non-scalable. If they wanted to scale, they'd have to add human resources, add people to the team, and train them, etc. And it is expensive. They've heard about machine learning. They want to try it. They already have those 15 years worth of original data, and they have their SQL database that has all data in, but they don't know where to start. They don't have an in-house expertise nor any resources to begin the annotation or the training process. So how can we? This is an example of the data that I mentioned. So on the right-hand side, you can see that we have the PDF file. This is the first page of a US patent application, which is what we're using for this example. I've highlighted the fields that have been manually extracted. So you have like the date of the patent, the application number, a couple of classifications as well. And you can see that this is the data that exists in BigQuery. So we have a link to the PDF file in a Google Cloud Storage bucket. We have the language, etc., and we have those extracted entities. So what we'll be trying to do today is use the existing PDFs and the data in SQL format in BigQuery to actually train a model. So let me walk you through the solution. And then we'll dig into each individual piece. So we're going to be using a Jupyter Notebook as an orchestrator to run all the code. We're going to use GCP with BigQuery, which will have our data, Cloud Vision, which will help us turn the PDF into text, Cloud Storage for storing all these results, and Vertex AI for doing the machine learning training. So as I mentioned, BigQuery, we're going to query the data set that contains the data. We're going to request PDF text extraction process from Cloud Vision for the PDFs. That data is going to go into cloud storage. The Jupyter Notebook code is going to read that data, combine it with the existing BigQuery data, and then create a data set that we will use to train a job for Vertex AI. Now, Vertex AI is going to retrieve the training data set, import file, which tells it, how to import a training data set from cloud storage, and then it will execute the training. Now, where do we run our Jupyter Notebook? I mean, the first option is clear. You can run it locally on your machine. It's free, but then you have to install that. If you're using a corporate or a corporate issued laptop, you may not have privilege to do so. You have to create Google Cloud credentials using service account, for example, to access the services. So it's a bit of a work. The other option is using Colab, which is a Google service for free, where you can run your Jupyter Notebook. And that's what we're going to use today. The one of the problems is if we're having a session that will last for a long time. So, for example, if we are doing a long-running operation like training the model, it may take hours. And Colab could time out, and then you would lose your context and the shell you're running the code in. But there are ways around that. I think you can either subscribe for a paid version, or sometimes it will ask you, are you timing out, or do you want to continue? So as long as you keep it in an active window, we can control that. The last option is using Vertex AI Workbench. And this is really our enterprise offering from GCP, where it gives you a VM, a powerful VM that you can run the Jupyter Notebook on. It's great if you're doing active development or if you need some underlying machine power, for example, to do some training yourself or some heavy data processing, or if you worry about enterprise security features, you're trying to access data that is secured, that is not available publicly, unlike our demo today, etc. Walking through the different pieces, does anybody have any questions? I don't see anything, so I'll pause for a couple of seconds. If everything is okay, I'll continue.
So far, so good.
Good, cool. So let's start with BigQuery. So BigQuery is our serverless enterprise data warehouse. I'm sure you're familiar with it. It has a feature that's called public datasets. So it has a collection of public data that you can access without needing to import it at all. In this case, we're going to use what's called the patent PDF sample public dataset. It has a collection of 300 plus patents. We're going to use 97 of those that are for the US Patent Trademark Office, USPTO, and that are in English. It contained links to the first page of the patent documents as well as the extracted documents. So this is really the data set that we're going to use for training, and it is the one that I've showed you before. Now, the next piece is the Cloud Vision API, and I talked about that in a bit. So on the left side, you see the PDF, and we're going to ask Vision API, which is a hosted version of an OCR model, an optical character recognition, that's going to read the PDF and extract text from it. And the result will be what you see on the right side, which is a bunch of text that's stored in a JSON file, which we're going to use to annotate based on the data from BigQuery. Now, once we've done those annotations, we've built our data set, we're going to send it to Vertex AI. And Vertex AI offers this AutoML training or slash model where you can upload your image, tabular, or text data set, choose what kind of model you want to train it on. In our case, we're going to use something that's called text entity extraction, which is a training method to train a model that will extract specific entities from text. So in our case, we're going to feed it patent documents and say, like, this is where the data is, this is where the application number is, this is where the inventor's name is, and train it on the existing data, hoping that we're going to get a model that allows us to extract entities from newer patent files that the model haven't seen before. So what Vertex AI does in the background, it tries various models using different combinations to give you the best performing one. And this is a funny cartoon from XKCD that talks about a conversation between two characters. One of them is, oh, so this is your machine learning system because it just looks like a pile of stuff. And the other character says, yes, you just pour data into the big pile of linear algebra, then collect the answers on the other side. And the other character asks back, like, what if the answer is wrong? And the answer is, well, you just keep staring until the answers start looking right. And this is exactly what AutoML is doing in the background. It's trying different algorithms to find out which one would give you the best answers, and then will give you that model. So it really makes it very simple and much easier for us to create models. Now, we talked about text entity extraction. I've talked about how you extract things out of text. This is just a simple slide to show you what that means. So on the left-hand side, we have the text. You pass that text through a trained machine learning model that's been trained on tens or hundreds of similarly annotated text. And then it will tell you, oh, I found this entity and this entity and this entity based on my training. So on the right-hand side, you can see it highlighted the publication date or the inventor line or the application number. And this is the model that we're going to try to train today. And one of the things that I love to talk about in this demo is the logic that binds the PDF text that we get after OCR and the existing data to build this import file. And I call it, magic wand. Unfortunately, I don't think I can use the word magic legally. So it's just some Python code that generates annotations based on that. So what it does, it will look into each one of those 97 files, load the text, and then go to the corresponding row in BigQuery and say, hey, I know that this is a previously extracted application number. Let me find it in the text and then build this JSON file that says, oh, I found this text at this offset, from this offset to this offset, and this is what I'm going to label it as. So it does that for 3 different components that I've chosen for the demo. So the application number, the filing date and the inventor, the first line of the inventors um, list. And then it builds this import file for the 97 files and then prepares it for Vertex AI to import that data. And with that, it's demo time. If anybody has any questions, let me know. Will just take me a minute to set up my screen for the demo. All right. So the first thing I'm going to do is go to this bit.ly link that I'm going to share in the chat. And the Jupyter Notebook that I'm going to demonstrate today is open source. So it's been published and shared on our Vertex AI samples GitHub repo. The link will send you to the GitHub link for that. So I'm just going to navigate there. And the cool thing about this is you can just click on a link and open it in Colab. Let me just increase the size a bit. Yeah, so you can click on this once you load it, and it's going to load it in Colab. And what I'm going to do is try to run through the various processes that I explained here. I'm going to expand all the sections for a start. Okay, cool. So the the Jupyter Notebook is going to explain everything that we're going to do step by step. So we'll talk about the overview of the solution, the objectives, what I just mentioned today, what are we going to do. It has a link to the data set that I mentioned, so you can take a look for yourself if you want. It mentions a bit about the cost, because if you're going to do that, it's going to cost you some money. And then it tells you how to set up your local development environment if you're running this locally. If you're not, which we're not doing today, we're going to skip that. And then we're going to start with setting up Colab. So we're going to start by authorizing the notebook and then running some code to install the dependencies, so the SDKs. And once that's done, we're going to restart the kernel, just to make sure that the additional packages are now recognized. And once we've done that, at the same time, we're going to create a new project, which I've already done in GCP. And you will get some errors. Those are minor, just warnings. So you can continue with that. This is an error, still works. We restarted the kernel, so that's good. And now we're going to, as I mentioned, create a new project, which I've already done. Created a Vertex AI GDG Montreal demo, and we're going to enable all the APIs. So there's a link that you can click here that will send you to a page to enable the APIs that we're going to need for today. And can you guys read the screen, or do I have to increase the size a bit more?
A little zoom in wouldn't hurt.
Yeah, makes sense.
Yeah, that's perfect.
Cool. All right. Cool. So we're just going to wait for a second until everything is done. And at the same time, I'm just going to set up what I need for the project ID. Vertex I, GDG, Montreal demo. Oh. So let's see. Yep, still enabling the APIs. That's fine. So we can set up the project ID. We're just going to make sure that it's configured. Cool. The next thing, while we wait for the APIs to be enabled, is really determining a few options. For example, when you're running Vision AI, you have the option of choosing whether to process the data in the US or the EU. We're going to default to the US for this demo. Same with Vertex AI. The operations that are running through Vertex, you can choose which region to run it in. And in this case, we are also going to default to the US for both regions. We're going to define a random timestamp that's going to be used in the creation of various files today, like the import, just to make sure that we don't duplicate data. And okay, the APIs are enabled. We can get rid of that. Next, we're going to authenticate our um, Colab account that we're using now with our GCP account, just to make sure that we can access that. Let's say yes. I'm using a demo tenant. So okay for that. That is done. And now we're going to create some of the stuff that are needed for the processing. So we're going to create a bucket name that's going to use that random timestamp that we said. We're going to make sure that we set the name, create it, and then validate that we actually have access to it. Cool. All right. And now we're going to define a few variables. We're just going to go by initializing the BigQuery SDK and the other SDKs. So like the Vision API using the region that we talked about. Same for Vertex. Same for cloud storage. All looking in order. Cool. And now we're going to dig deep in. Sorry, Ceci, what did you ask about for Canada?
Yeah, we're just wondering because you said you can actually like run your stuff in US and in Europe. So I was
Yes.
wondering, so if eventually Canada with two regions now can actually one day maybe.
Yeah, good question. I don't have I don't know about the roadmap for Vertex or any of those services, but that's a very good question. Yeah, I hope it does.
Get feature requests.
Yeah, sure. Okay, so now we're going to query the data. I just want to make sure that we can access it. Yep, we retrieved 97 rows, and we're using Panda to store this in a Panda data frame. For anybody who wants to dig deeper into Panda, you can read more about it. But we're just using that to store the data from BigQuery, so we can manipulate it internally. I'm gonna print like 5 rows just to show you that this is the data that I've shown before. That includes the path, the different extracted entities, etc. Now, for some processing data, we're going to take away, the path here. So there is a function that I'm going to run to just extract that out and just leave the name. So just really extract the file name so that we can match it later on when we do our processing. And now we have that data ready. We're going to create our import file. So the first step, as I mentioned, is we're going to use Vision API to go through the 97 PDF files and switch extract text out of those. For that, there is code that will run a number of add a number of requests um, and bulk them together and send an asynchronous request to Vision's API to extract text. So this code goes through that. It loops through the BigQuery dataset, looks for that GCS path that we had, and builds an array of requests to do processing, and then sends that over to Vision. So we're just going to wait. This may take a minute or two. And the files will be stored on a Google Cloud storage bucket that we're then going to read and use. All right. Usually takes a minute or two. And I'll talk a bit about the next step, which is generating the import file. So you remember when we talked about, looking at the text, like the extracted text from the OCR job, and then comparing all the different entities, the 3 ones that I talked about, the publication date, application number, event line. This code does that. So this code goes through all of the results from the OCR um, and goes through the BigQuery dataset and matches that with the text that we got from the OCR and builds the JSON line file. So just a text file that has multiple JSON objects, one each line, that contains the annotations that we're going to feed into the next step. So that's perfect. We got the OCR files done. Now we're going to build that file. And really, this is I would say, the brain of this, notebook. It's like taking that logic to create this import file from all the data that we have. And that annotation file has now been created. We're going to upload it to GCS. So we can see that this is a path for it. And now we're going to ask Vertex AI to create a new data set using that file. So this can take a while. And the next step will be actually running the training. But I'm not going to do this now because it's going to take hours. I think the last time I ran it, it took like 2.5 hours. But I'm going to switch to showing you the data set that I've uploaded for a previous model. Same thing. I've run this code about, some time ago, um, about 2 weeks ago. And this is what I'm going to show you. So if we go to data sets, you can see the data set that we imported into Vertex. And you can see we have 97 files. So those are the files that we've, or these are the files that we've uploaded, or the file content that we've uploaded. And hopefully in a few minutes, we'll see the text pop up. Let me just see. Oh, this failed. Interesting. For whatever reason, we failed the import. Okay, time to debug later. Okay, so this is the data that, again, should have. I don't know what the problem is with that one because it ran fine a week ago, like 2 weeks ago. But if we look at the different, data sets that we've imported, it takes a little bit to load, but then you can see the actual text. So the PDF file was transformed into text, which what you can see now. And based on that logic in the Jupyter Notebook, we've annotated the text with extracted document entities. So in this case, you can see it highlighted the inventor first line for our demo, and it says like this is inventor line 1. It did the same for the application number, and it did the same for the publication date. And it did that for the 97 documents. And what we did after that is feed those files into a training job. So the training job ran for about 2 hours and 28 minutes. And out of that, we got a model that we can actually test to show you how accurate that model is. And I apologize, I don't know why it's a bit slower than usual today. And I'm going to take a look at why it failed after, just to make sure that the code is still intact and everything is fine. But in the once you've done the training and trained, there is a sample. There's a way to evaluate the model. So you run an evaluation to see how good it is, and then there is a sample test item. So this is a sample pattern that was not included as part of the data set that I was going to use to test the model. I'm guessing maybe. Okay, cool. So we're starting to see the results from the model that we posted before. So this is the confusion matrix, which shows, what were the labels that we identified or told the model. So when you upload the data set, there is a way for you to split your data into 3 different categories. There is the training items, which are used to train the model. There is the validation items, which are used, internally by AutoML or Vertex to test each model against to see like how accurate, how good it is. And there are the test items which are then used to test the performance of the final model that's chosen. So in this case, the default split, I think it's 80, 10, 10. So you get 80% of data set as training, 10% or so as validation, and 10% as test. And the confusion matrix, you can read more about it online as it explains all different pieces. But basically what it shows you is when we're looking at true labels, so the things that we've told the model to expect, how many of those, or what's the percentage of those that were protected? So we show for application number, 100% of the labels that we've manually annotated were detected by the model. 89% of those were detected for the inventor line. 11% shows null, means they were not detected, and then 100% of the publication date. So across all of that, you can see that the precision of the model was about 93%, which means this is the percentage of predictions that were correct. So when the model protected stuff, how accurate was it? It's 93%. Recall is another metric that's used that shows you the percentage of all ground truth items. So the items that we've manually annotated and used for testing, as far as I recall, that were actually predicted by the model. So 96% or so. Now, based on the limited number of items that we had, which is 97, I think this is an amazing result. Within 2.5 hours using existing data, we reach a model that gave you this performance. Now imagine, what can you do if you increase the number of items, or you've had, instead of 97 documents, 1,000 documents. I'm sure that we'll be able to hopefully improve the performance for that. Any question? This is all about like the model generation. If not, then I can move into like deployment and how to test that and integrate it with Google Workspace.
There's a question from Elizabeth saying, like, does it need to be stored in the model registry?
That's a good point. I haven't taken a look at this lately. I know that it used to show up in the model when you train it. Um, so models are built from your data sets. I'm not sure if there is an alternative to doing that, Elizabeth. I thought that once you train it, it just shows up in the model registry. Are you talking about downloading the model, like to use it offline? If you can elaborate, or I don't know if you can unmute yourself or join, maybe not. Yeah, probably. I think I know AutoML for some scenarios or some models, it allows you to do what's called an AutoML edge, which is really a process that's a bit more expensive. It is more expensive to train that kind of model. But in that case, you can actually download the model for use offline. So if you wanted to include it, say, as part of an Android app, or using the TensorFlow, I forget the name of like a TensorFlow Lite, I think, which you can use in a web application, then you can use that. I think for the entity extraction, my understanding is that's not the case, or at least not in our demo. We're just using it. We're training a model that's stored in the model registry, and then we're using that to deploy it. So if we look at the model, I can show you that it's deployed to an endpoint that then we're going to call via an API call. I hope that answers the question. Cool. All right. So the next step that I'm going to do is just show you talk a bit more about how do we use this model. So now that we have the model, we went through the demo. How do we use it? So you can deploy the model to an endpoint, and that endpoint means that you now have an API endpoint that you can submit a request to, and you can use that any way you see fit. So in my case, as a new partner developer advocate for Workspace, I get to work a lot with Google Workspace as a platform. And I don't know if you're familiar with this or not, but Google Workspace is our commercial business offering for the products you use and love. Gmail, Calendar, Meet, and Drive, and the editors, Docs and Sheets, and all of that. And you can actually extend that using a few tools. So we have a no-code tool called AppSheet. We have a low-code. It's called AppScript that allows you to just code within the like you can go into the editor and just create some code to manipulate the sheet, etc., for example. But you can also build an add-on that you can publish on a marketplace, either the marketplace for your organization if using this internally, or even to the public users. So really, Workspace is becoming a platform where you can build and deploy applications on, again, either for internal use within your company if you use Workspace, or for the public as well. We also are building, chat apps. You can use, different APIs, and as I mentioned, deploy this to the marketplace. And with Workspace, of course, you're not limited to using that with GCP. You could use that. You could use, any of the other cloud providers, etc., or databases. Now, the demo that I'm going to do involves just using those API endpoint, which I'm gonna show you in a second. You can show the model that that I deployed a couple of weeks ago, and you can see there is an endpoint. And if I click on that endpoint, sample request, sorry. Okay, I should have clicked on that. There is a place where it will show me how to send a sample request. So you can see that I can use this endpoint, including my project ID and endpoint ID, and send this kind of body to get the response. Now, it's a bit more involved. You may have to dig, into the documentation a bit more to find out exactly what do you send and what do you get back. But really, that's it. Of course, you need to be authenticated. So there is a separate process about like getting, a bearer token for authorization that you can also read about in the documentation. But the example that I built is this. Imagine you're using Gmail or Google Drive and you have one of those PDF files. So we've trained our model, everything is fine. And now we're looking at how do we ingest the new data. So I've created a sheets that I said, oh, I'm going to track any new documents that comes my way, and I need to extract all these entities, but I don't have them yet. So one way is receiving an email. So let's say somebody, Stacy, somebody else I'm working with, sends me an attachment and says, oh, this is a new patent file. Just get that into the system. Now we talked about, previously we used to do this manually. Now all you have to do is use an add-on that I built. So on the right-hand side, I've built an add-on and I've deployed it to this, demo tenant on Google Workspace.
Can you
And
zoom
once
in
you,
just a little bit? Sorry.
sorry,
If you can zoom in just a little bit.
yes, yes, yes. Thanks
No
thanks
problem.
for it. Is this good or a bit more?
Yeah, no, that's good. Thanks.
Yes. So once you go into Gmail, I've deployed this add-on that once you launch, it says, "Oh, this is you're launching me to process a patent file." You click on this, and what will run in the background is this app script code that I can show you quickly. That's going to reach out to the API endpoint, feed it. It begins with sending a document OCR request. In this particular, I actually use doc.ai OCR processor, which is a separate process, just that the Vision API PDF to text extraction only works as an asynchronous process. And for this demo, I needed a synchronous process. So I use another product from Google called doc.ai or Document AI, where we offer different processors to process different types of files. One of them is just doing an OCR. So it takes that text and then it feeds the text into an AI endpoint, the one that we deployed, gets the entities back, and at the same time puts it into sheets. So if we go back to the sheet that I had open, boom, you can see that the data is there now. And it does that in a matter of seconds. Now, in a different scenario, let's say that somebody doesn't want to do this through Gmail, they just upload files into Drive. So the add-on that I've built, it can be configured to be deployed to multiple products. So the same add-on with a slightly different coding also works with Drive. And I've enabled that. So again, on the right side, I click on our GCP Vertex AI AutoML demo, and then let's say I select a different file. This is another PDF, and I say, oh yeah, let's process that one. Again, does the same process, send it to doc AI for OCR, then does the model prediction through the text, through Vertex AI, and boom, we got the new entry here. We can just as easily repeat the process for another file. Same thing, process, and poof, we've got the same file. So for each one, if you want to like double check, you can see this is the first file that we processed, for example, and the different things that we've extracted, like the first line of the inventor, Zhang Hyun Ryo, that's the same one, the application number matches, all of that. So really, all of this is just to show you how easy it is to integrate the APIs and also how easy it is to build on Workspace. Just quickly, I'm gonna just show you a quick demo. Like this is the IDE for AppScript, which is the IDE, the web-based IDE that you use to develop your add-on or your code. Just shows you like the different codes. It's using JavaScript modified slightly, uh, you know, um, and yeah, you can use that to retain what kind of um, interface you want or not. And with that, I think we're done. Just gonna give you a quick few last pointers, I guess. And as I mentioned, we've went through explaining how you can process the data set using Vision API and BigQuery. I know it was a lot. Hopefully, this is recorded. You can go back to it and check it if you want. We've demonstrated how to do it in Jupyter Notebook. We've shown you how to evaluate the trained model and look at the statistics and how to have an actual use case using Workspace. Now, you can give it a try. This is the link that I've shared before. If you are able to send me feedback on this session, that'll be amazing. I'll post the link as well. And you can also check the complete repository for Vertex AI samples that includes tons of other data. So for example, I know I've built another integration or another Jupyter notebook that only process the PDF files and give you the text files. And then you're ready to do whatever you want with your model. So there are tons of other more interesting examples as well that you can dig deep into. And that's it on my end. I'm happy to answer any questions if you have any. Back to you, Stacy.
Cool. Yeah, feel free to ask questions, and thanks for that. That's actually the that integration with. Let me turn my camera back on. But yeah, no, the integration on the, like, let's say the business side of things, like having like straight into Drive, just like dropping it, and it's just that's pretty cool. So it
And
it it kind of obfuscate the Google Cloud platforms. Yeah, I just want to use this thing and just feed it, which is quite nice, to be honest.
And yeah, you can even like add triggers. So the minute you drop a file in Drive, it automatically processes the data and like deletes the files or move it elsewhere. So really the workflow is what matters. Is you've built a model now. How do you use it in an actual scenario? And if customers using Workspace, yeah, that would be the easiest way of doing that.
That's no, that's cool. Yeah, no, the workspace integration with the like the even the low code. Um, we're shameless plug. We're using it to do our own Go link internally. Like
Uh-huh.
you know what I'm talking about. So
Yeah,
for people who are not aware, inside Google there's a Go slash something that it makes you just go faster looking for something. So we did the same thing, like I saw, but through the low code piece where you install a little plugin and then we do like Go slash something and then go
nice. Yeah.
you can do your thing. So it's a nice little addition. It brings something that people sometimes don't think about, like workspace is just your stuff and drive,
Exactly,
but it does
exactly.
way more too. So
And
awesome. No, that's
to your
cool.
point, you can do it for your company. You can even publish it publicly, like whatever the use case is. Cool.
Yeah, no, it's pretty cool. So oh, so yeah, no, Manal is thanking us, so thank you, Manal. So
Right.
awesome. So I'll just hijack your shared screen.
And
Yeah,
I
and I'll
think
just wrap things up.
there was one question from Manal. Manal, I think there is a blog post where I posted this, and I think it should be in the in I think it was in the um, GDG meeting link. I'll post it again now. So there is a blog post that talks about the solution and link to everything, and that one has the actual um,
Cool.
that has the solution diagram as well.
Awesome. Great. So yeah, so we're wrapping things up. We're at 1 p.m. So that's been good. It's been good. So yeah, well again, like thanks everybody who showed up. Like the recording will be put in our YouTube channel as usual. So if you want to replay it with your family in the weekend, feel free. So there's also like upcoming stuff. I mean, like we have a Q4 event like every quarter. So feel free to if you have a talk feel free to scan the QR code, submit a talk proposal. We'll get it on our side. For Q4, maybe we'll try to do two, like we did last year. So we have next coming in October. So there's usually like a next extended that we do, which will like sum up everything that happened at next and put it in a GDG Cloud Montreal session. And then we'll find another talk for the end of the year. So please free to submit anything. We'd love to hear about user stories, the way you're leveraging GCP. We'd love to hear you. So don't be shy. Yeah, so just gonna wrap things up. So like again, thank you everybody. There is a also like you'll probably receive an email also like from the platform for a little survey. Just to, keep us honest. What would you like to hear in upcoming events and all that. So we are. At one point, we'll may be able to go back like in real life. But for now, the remote seems to work quite well. And yeah, so feel free to keep following us and give us a little feedback, and we'll see you basically for Q4. So again, thanks everybody for attending. Mohammed, was super great to you. So it was a lot, but it shows the power of what can be done. So there's a lot of magic under the hood. Yes, we're not supposed to say magic, but anyway, but it's like
Yeah.
but there is a lot to learn. So anybody that was here that's doing that's playing with Vertex or wanted to play with Vertex just got a little look of what it could look like and more with that
Yeah,
workspace.
and then feel free, to reach out to me on LinkedIn. You can find me there. And yeah, and then just report like that error that we saw earlier. Apparently, was just a fluke. I retried it. Everything is fine. So you can try the code. You can run it. Everything is fine.
All right, excellent.
Cool.
Well, thanks again,
Thank you.
everybody, and we'll see you next time.